All right, let's get started. Welcome to the session on type inference, friend or foe. My name is Venkat Subramaniam. We're going to talk about type inference in Java, but I want to kind of take a little bit of a broader look at it so we can better appreciate type inference and use it where it makes sense. So there are three parts I'm going to talk about in this particular presentation. One is what is type inference? The second is where it's really good to use. And third, where we are better off not using it. So that's basically what I'm going to cover. So let's get started. Well, I want to first talk about static typing and static type languages. Type inference really makes sense in a statically typed language, and there's a lot of really powerful static languages that do use type inference. To name just a few here, one of the languages I appreciate really a lot, which is statically typed. In fact, before I learned Haskell, I had a very different view of what static typing is. And Haskell is probably one of the most powerful statically typed and yet a functional programming language. Let's quickly take a peek at Haskell just for knowledge's sake. I'm going to bring up the Haskell REPL right here. And within the Haskell REPL, I'm going to ask it to display the type information for us to know a little bit about what type we are looking at. And I'm going to define add A and B equal to A plus B. But before I run this, let me tell you this. I failed at learning Haskell 3 times in my life. And I kind of tried and retried, and I was thinking, why am I having so much difficulty learning Haskell? And then I really realized the reason was I was having a really hard time specifying all the type information. And then I suddenly realized that Haskell actually cares less. It can do really a good amount of type inference. And here I was trying to work really hard and doing what Haskell can do really well. So I started programming in Haskell without putting type most of the time, and it simply just works. As you can see right here, it clearly knew that the A and B are numbers, and it was able to infer the type very clearly. So that's one of the things about static typing is that the type information can be verified at compile time, but the language potentially could infer that as well pretty effectively. So if I were to call 1 and 2 for the add, it gives us a 3, which is again a number, as you can see. But if I were to try to send maybe a test over here, that clearly fails, as you can see, because that's not a number and the compiler doesn't really like it. So you can see how type inference can play a really good role when it comes to languages that can use it very effectively. Other languages that do this also are languages like Scala and Kotlin. The point I'm really making is that type inference is very popular in languages outside of Java, and that is something that we can really embrace. And then more and more we work with other languages, we tend to really use them pretty effectively. Languages that are actually moving towards type inference, I would say, are languages like C# and Java and C++. Those of you familiar with C++ know that C++ has auto over the past few years, and this can be really a good way to infer the type as well. But it turns out Java has actually had type inference for a very long time, and they've been gradually introducing type inference for us starting from Java 5. So let's revisit type inference just a little bit, and if we don't like type inference, we can think about how horrible life would actually be in Java for the past about 15 years, if you will. So let's take a look at a quick example of this just to see how this would actually end up being without really using type inference. So let's say for a minute I have a list of string, let's say, that I want to create. I'll call it as names is equal to new array list over here. And this is going to be a string. And then I want to add a name to this particular collection. And the way I'm going to add a name to this collection is I'm going to say add over here and add Jack to this. And I'm going to say names.string. And then I'm going to call add again and add Jill to it right here. And then when I'm done with it, I'm going to simply display the names that I have added in this collection. Now, when you look at this code, how many of you write code like this using generics? If you do, please raise your hands. Not a single person raised the hand. I had the wonderful opportunity to work with a project which I would say from hell, because this is how we had to write code in it. Because the data types were so complex that it was not a simple angled string. It was usually a massive amount of type information you have to put here. And every generic call we have to make, we have to sit and put all this angle, and we really hated our lives. We had to really make take all that work and it's miserable. But the beauty of this is the following. If you really don't like type inference, I have news for you. From tomorrow, you have to write code like this. Because that's what it means that I don't like type inference. I'll put the type every corner I turn. But we have been using type inference for a while, and as you can see, this code is working, but I can remove that part we just saw there, and the code is still working, as we can see, and that's because we have been using type inference quite effectively in Java, and right there, the compiler was able to infer the type for add and say, yep, that's going to be a string. We didn't have to really specify that. That was really a good news. Well, but also, though, when type information is needed, you have to really specify it. There are some of the limitations that you would run into, like the project I worked on. It becomes really miserable, but that's when you really appreciate type inference being there for you. Well, in Java 7, of course, we have one other benefit. We have the diamond operator introduced in Java 7, and as a result, this code becomes just a little bit better. We don't have to specify the string over there on the right side, and we were able to use the diamond operator right in there. Well, that was Java 7, but unfortunately, there was a limitation in Java 7 when it comes to this. If you're still using versions of Java before Java 9, what you will run into very quickly is the following. If you were to write the code like this, for example, where you were to move this inside of this, if you will, and I'm going to just call the add method right in here, unfortunately, this code will not compile in Java 7. This code will not compile in Java 8. So this will be an error in both of those versions of the language. And that is because in Java 7, this was an error because you cannot have anonymous inner classes with diamond operators in Java 7. And of course, I'm not using Java 7 here anymore. I'm actually using Java 11, and that's no longer a restriction starting from Java 9. This code will actually work in Java 9 and later as well. So if you're using Java 8 or Java 7, you would not be able to compile that code. Java 9 and moving forward, that is an improvement already, as you can see. That's one of the benefits you get also by using type inference at that point. Let's move a little forward to Java 8. And Java 8 has one of the most exciting concepts in modern Java, in my opinion, which is the Lambda expressions. And Lambdas, of course, have type inference quite healthy. For example, let's say we have a list of numbers, and I want to iterate over these numbers and print the values. So I'm going to say numbers.forEach over here. And within this, I'm going to say integer element, and I'm going to output the element given to it, and I'm going to run that and print it. But if you notice over here, you are saying that when you're doing an iteration on the collection of values, you're going to iterate over integers. Let's think through this for a minute. If I give you a collection of numbers, and if you were to put your hand into this collection and pull a random element out of it, in your wildest imagination, can you think of what type it would possibly be? A dog? No, it's got to be an integer. Well, you know it, and the compiler knows it. Why bother saying the most obvious, right? So this is one of the rules I follow in life. Never say what's really absolutely obvious, because everybody knows it. So you can drop the type information right there, and that is type inference. Make no mistake, at compile time, the compiler clearly knows what type it's dealing with. So if I were to call a foo over here, carefully watch the error you're getting. E.foo, variable E of type integer does not have it. So the compiler clearly knows it's an integer. There is absolutely no ambiguity whatsoever. So the compiler is quite happy with it. Now the benefit of doing this, of course, is you can remove that silly parenthesis as well if you are only using a single parameter. And so the code becomes a lot more concise and much more easier to work with. Obviously, you could even move towards a method reference if you wanted to, but the point here is that you're able to use type inference really nicely. So this is, again, something that's really welcome, but of course, that also comes with a few limitations, if you will. The first and foremost limitation is that you cannot place annotations in Java 8 if you're using type inference. This is a bit of a drawback. For example, if I were to go back to this code, I want to put an annotation like final, if you will, or I wanted to say not null and things like that. I can do all of this when I have specified the type information. On the other hand, if I do not specify the type information, I cannot put the word final or other annotations. That is a limitation in Java 8. So if you're using Java 8, you cannot use type inference if your parameters required some kind of an annotation, like a not null or final or anything else you want to put, tough luck, you have to go back and put the type information. That's one of the limitations you will run into. But there is yet another limitation, and it's really important to understand these things, because if we don't, life becomes very frustrating. So as an example, let's say we have a sorted, I'm going to call on this one, and I'm going to then simply print out for each, and I'm going to simply print out system.out and I'm going to just print this out. Now, in this example, if you notice, what is the sorted going to really do? I'm going to bring in the comparator, if you will, and I'm going to bring in the static methods in the comparator. So I'm going to say over here, comparing, and in this case, I'll say integer element, and I'll simply return the element. I'll call reversed on this one, and I'm going to go ahead and run this code, and you can see that it printed things in the reverse order. Now, obviously, in this case, I did not use type inference. I provided the type as an integer, but for a really good reason. This is one of the places where you really have to understand when Java is working for you, because there'll be a time when it doesn't, and you'll get really anxious why things are not working. So if I remove this and simply put a type inference like this, in fact, let's go ahead and remove the reversed for a second and run the code. Notice that just worked. But if I put a reversed right here, you're going to struggle with this and say, why in the world that doesn't work? On the other hand, if I were to put the type information right here, notice that actually worked. Now, these things will appear really strange, but only if you haven't really taken the time to understand type inference. But what's happening in this case is, when you look at the comparing, the compiler looks at this and says, hey, what is the type of E? And the compiler says, gosh, I don't know. Let me check my neighbors, and goes to reversed and says, reversed, what do you think my type is? And reverse says, I don't know. It's whatever you are. So that doesn't really help at all. There is not enough context in this case, and that's why it's failing. So once you understand that context actually matters, then you know why type inference works, and when it doesn't work, it becomes really easy to work with it. Like I said, Java 9 introduced the support for anonymous inner classes with diamond operator as well. We saw this a few minutes ago. Now let's talk about Java 10. Now Java 10 is the one that stirred up all this conversation, isn't it? We've been quietly, happily using this, and nobody even sneezed about it. And the minute Java 10 introduced type inference, everybody got angry with it. And that's what really surprised me, because this is something we've had for a long time. It is nothing new in Java. They just added one extra feature, and then we are really up in arms with it. There's no real reason to do it. Like I showed you, up to this point in the past 10 minutes or so, maybe 15 minutes, I didn't even touch Java 10, and we still saw type inference we've been using quite happily for a long time. Now let's talk about Java 10. What does it really provide? In Java 10, local variables can be type inferred. So what does that really mean? Let's understand this with a little example. I'm going to say string greet is equal to hello, and then I'm going to go ahead and output the value of greet right there, and you can see that it displayed the hello as the value. Now, when you look at this particular line of code, you may wonder what is the type of greet, and clearly the type of greet is string. But we know that not because we said it's a string, we know that very clearly because we are assigning a string to it. So as a result, we could have simply said var over here, and that still works. Let me emphasize one thing before we go forward, because sometimes I hear people say this, they say it's a var type. Let's make this very clear. There is no such thing as a var type. There is absolutely no concept of var types. All this is saying is to the compiler, you're saying, hey, compiler, rather than me typing all that information using my fingers, why don't you just go figure it out for me? Because I've given you enough context already, and you can find out what it means based on this particular context. So var simply is a little wink at the compiler to go tell it to go find the type of this variable at compile time, so you don't have to sit there and type the whole thing over and over and over. It's kind of like somebody comes to you and says, what's your name? There are two ways to answer it, right? You can just tell what your name is, or you can say, my name is, and then say the name. But the second one is a boring people, right? When somebody asks you what your name is, why would you give somebody else's name, right? So it's obvious it's your name. That's kind of the context over there. That's what it really means in this case. Now, make no mistake in this particular case, if I were to say string over here, and if I say greet equal to 1, carefully notice the error that you are getting. It says incompatible type, int cannot be converted to string. That's the error you're getting. Just look at the line number 1, incompatible type, int cannot be a string. If I modify this to a var and run it, it's exactly the same error, no difference whatsoever, because the compiler has decided that greet is a string, and so it tells us we cannot assign a number to a variable that's of type string, so it clearly knows that as well. This is only true only when the compiler is clearly able to determine what the type is. Now, there are two criteria that I use for type inference. One, the compiler should be absolutely clear what the type is. And second, the human programmer should be absolutely clear what the type is. Don't ignore the poor human, right? They are important too. So just because the compiler figures it out doesn't mean anything. It's important that we figure it out as well. That's very critical. This is only for local variables, but we can actually extend this for quite a few things, if you will, within local variable scope, that is. So I can say int, for example, let's say string name, and I'm going to say this comes from names over here. And then, of course, I can output the name value, where we could say that the variable names is going to be, let's go ahead and say this is going to be arrays.asList, and we will again say Jack and Jill over here. So when you look at this code example, we are printing Jack and Jill as the value right here. But looking at this code, we clearly know that this particular name is a string, so you can just drop the var in there if you really wanted to. There is absolutely no reason not to do that. So you can say for var name is :names, and you can use it in the context of a for statement as well. That's perfectly fine, as you can see. So you can use it for a local variable like we did a few minutes ago. You can use it for a for. You can also use it for a try as well. So you can put the type as in a try catch, that is. You can say catch exception. You can put a var for the type as well if you really wanted to. You could do that. But as of today, you cannot use this for fields. Now, don't assume it cannot be done for fields. Java has not done it, and I'm not sure if they will ever do it, but don't be surprised if it ever happens. Maybe they are just waiting for us for the shock to sink in, and once we are used to it, maybe they can do this for. Languages like Scala will do this for fields as well, but not Java at the moment. So, for example, if I say int value equal to 4 over here, and when I go ahead and execute this code, there was no error, as you can see. But if I try to change it to a var, the compiler says var is not allowed in here, so you're not allowed to put that in there, as you can see. So you cannot do this for parameters as well. I'll admit, one of the things I'm not too happy with Haskell is that in a language like Haskell, let me put an error right here. This is one of the dangers of writing code live here. People then tweet it, and somebody says on the Twitter, this guy's an idiot, this won't work. So I'll just put the word error. Now you can take the photo you want to. So the point really is that when you deal with language like Haskell, this is one of the things that scares the heck out of me in Haskell. In Haskell, when you don't put the type of parameters, Haskell will go deep into the method and come back and say, look what I found, and we'll tell you what the type of the parameters are. Scala doesn't do that. Kotlin doesn't do that. I'm happy for it because to me, the parameters of a method are really integral part of the signature, and I want to make that really stable. So here I actually disagree with what Haskell is doing because I think it's a little overreaching in my personal opinion, but of course Java doesn't support that as well. So if you were to go ahead and write a method, if you will, let's say public void foo int a, and then of course in this case, let's go ahead and say this is going to be int, let's say input, and I'm going to then just go ahead and output the value of input. The compiler is happy with this so far, but if you were to change it to var, that would not be permitted, and the reason is there is not enough context to figure this out, and like I said, even if there were a context, I don't think that's really a smart idea, so the language doesn't do that. Now, there are a few things you have to be very careful with when it comes to type information. Now, before we go further, there are something I really like in the language, and that is, let's say we have int, let's say value equal to 4, and I want to output the value right there. Now you can clearly use the var here, and you can write it this way. I want to emphasize one thing though, just like there is no var type, keep in mind that var is not a keyword. And I really like languages that don't have as many keywords. Now, the problem with language like Java is, if you introduce a new keyword, you have to fight against 9 million programmers. And they're going to say, I already use a var, what the heck are you talking about? That becomes really hard. So if you really want to mess with the colleague of yours, I've got an idea for you. You can say var equal to 4, and then you can output the var, go for it, and just watch their face turn color as they see it, right? I am not suggesting you do this, but if you do, never tell them I told you to do this. But the point really is that it doesn't really care. Var is not a keyword. The first occurrence of var simply winks at the compiler to find the type of the variable whose name is really var. So var is not a keyword, so you can write something like this if you really wanted to. And of course, you can push these boundaries a little bit and see how far it's going to go, but these are purely for exercise and fun times. Don't really do this in production code, right? Be gentle, be kind to your developers. Don't torture them with the code like this. So you cannot have a class called var for really good reasons, right? So there are some limitations you will run into, and you will figure this out. The compiler will tell you very quickly if you're violating those. Let's talk about a few caveats where we have to be very careful using some of these things. One of the things you have to be extremely careful about is that when you are using var, you have to really ask the question, what am I conveying to the compiler? Now, this is one area where I would emphasize, if you are taking existing code and you are refactoring the code to use var, I've got two suggestions. First, don't. There is really no reason to do this, right? So if the code is working, everybody is happy with it, leave it alone. There's more important work to do than change everything to var. Second, if you do have a reason, maybe you are saying, oh, Venkat, that's a great idea, but I am actually actively refactoring this code. Can I change it to var? The first and foremost thing is, how good of an automated testing do you have in your application? If you have a solid automated testing, go for it. If you don't have enough automated testing, you are better off leaving that variable as it is than converting to var, because the result may not be what you thought it is. Now, we're all smart people. I'm not doubting that at all. But we're also people who don't think clearly when we are under stress. And when we are coding, we're always under stress. And the point really is, when you're looking at the code, your mind kind of tricks you. You think it is one thing, but it ends up being another thing. It's not worth it. Let's look at an example right here. If I have a list of string over here, stir, let's say list, or I'll call it as names is equal to, a new array list over here. And in this case, of course, I can say string, and I can write it this way. Now what can I do here? Names.add, I'm going to say Joe right here, and I'm going to check if the compiler is happy with me, and clearly the compiler is happy with me. But on the other hand, I'm going to say names.add, let's say 4, that clearly will not work because it's an incompatible type. I cannot send a 4 to it. No worries at all. let's go a little further. Well, let's apply Java 7 type inference, get rid of that string, and we use the diamond operator. Curiosity's sake, let's come and check on this one, and the Java compiler says, I'm still watching you, what are you trying to do? Well, never mind, sorry, and that worked really well. Now I go back here, and then I change it to var. What is this called? Some people call it refactoring. I call it bad idea, right? Because what did we just do right now? What we just did was ask the question, what's the type of names at this point? Well, remember, the compiler can only work with what it knows. And what does it know? Not a whole lot. So as a result, the compiler is so happy that names is actually an array list of object type. So if I were to go back here, the compiler is like so happy and says, okay. So don't just happily go start changing code to var. We have to really know what we're doing. I know you're protesting. You're saying that's called programming. We always have to know what we're doing. I agree. But in this case, especially, we have to be still awake when we are trying to refactor the code. Otherwise, the behavior can be really unpredictable. So don't do that. So when it's a diamond operator, it makes 0 sense to use a var on the left side. I'm hoping eventually we'll have lint tools that'll yell and scream at us and say, what are you trying to do? But until that point, we have to be just careful about it. This doesn't make any sense at all to write code like this. And of course, so don't use it with the diamond operator. One other thing you have to be very careful with is there are some really nasty scenarios in Java. They're not new nasty scenarios, but those nastiness really come to surface one more time when it comes to var. So let's look at an example. Let's say collection of integer, and I'm going to say list is equal to new array list. And in this case, I'm going to say this is a list of integer as well. And within this, I'm going to simply say add 1 and add 2, and let's say add 3. So I'm going to put 3 of those to add right there. I'm going to output the list right here, and I want you to know it's a value of 1, 2, and 3. I'm going to say list.remove 0, or remove 1 rather. I want to print out what the list is. I want you to carefully keep this in mind. Notice the output is 2 and 3 in the very end. So the output is 2, 3. Let's verify that one more time, and you can see it is actually 2 and 3 in the last one. However, I'm going to just go happy on this again and put a var here. This is also known as bad idea. And when you run this code this time, notice the result that was 2 and 3 now is actually 1 and 3. This is not going to be a lot of fun when the behavior is very different. Like I said, this is not a problem that started in Java 10. It's a problem that started in Java 5, actually. But it's just blowing up one more time when you start using var. Little things like this can be really annoying. So don't do that. If you're interested in knowing why this actually failed, look at the signature of remove in the collection interface, and look at the signature of remove in the list. It's a failure of the list-off substitution principle. It was a poor design decision, but it just manifests itself in yet another way in here, so we have to be really careful about it. Similarly, if you have a base class versus a derived class, you could be in real trouble with this. For example, let's look at this really quickly over here. If I were to say, let's go ahead and remove all of this for a second. If I said list string, and I'm going to say list is equal to, names is equal to, let's go ahead and say new array list of, let's say, string for a minute. And you know what the type of names is? The type of names is a list. It is not an array list. If you change it to a var, now the type of names is an array list. So in other words, it would become the type of the derived rather than the type of the base type. And that is something you have to be very careful with. Why is this important? Because a lot of times you want to call the method of the base and not the method of the derived. And you want to rely on polymorphism in those cases. Remember the sage advice in effective Java, as much as possible use the interface reference rather than class reference. You might be violating it in this case, so just be aware of that, something for you to keep in mind. You cannot use this to store Lambda expressions. Now, let's give it a try really quickly. Suppose I were to create a runnable is equal to And I'm going to say a runnable doesn't take anything. I'm going to output you called right here. And then I'm going to say runnable.run and execute that little runnable. Now, if you look at this line of code, notice where the context is coming from. The context is actually coming from this runnable, because if you only look at this lambda, there is not enough context as to what the type of this lambda is. Now, as a result, if you were to now go ahead and say something along the lines of var runnable equal to runnable, the compiler says, come on, give me some help here. I don't have a clue what this type of lambda is, and as a result, it cannot really do that for you, and that actually fails. So I'm going to say you cannot use var to store a lambda expression. But you know how some programmers don't take the word no for an answer, and these are dangerous programmers. And what will they do? They will say, really? Let me show you how. And they will then do something absolutely ridiculous. They will say runnable over here, and then I'm going to say really, right? So this is really stupidity, right? So don't do this. So when I say you cannot, I mean you should not, right? That's what it really means. So please, okay, people are taking photo. Please don't do this. So this is not a good thing, because this is really trying to prove a point which is not worth proving. So don't use this, because it only makes the code ugly. If the goal was to use var and make it really ugly, I think we achieved the goal, but there's really no reason to do it. So don't use var to store lambdas, because there's not enough context to really store it. And so that's what I said, seriously, don't do that. And let's talk about some benefits of doing this. So what are some of the benefits of using vars, type inference? The first is, I'm going to argue reduced clutter. Now, what I mean by reduced clutter is not as much as when you have an int or a string, but when you really have this massive map angle bracket, type 1 comma, list angle bracket, another type angle bracket, and by the time you put all of that, it looks really nasty. The other day somebody said, aha, I never typed that myself. I right-click on my IDE, and before I could blink my eyes, my IDE vomits all the type on my screen. Exactly the point. You still have to deal with that vomit, and the vomit only begins to smell a lot more as time goes on. But you can use a var, and you don't have to deal with all that vomit. Even if you have a good IDE, you can spare your team from those vomit in the code. That is one benefit you're going to get. So it's reduced clutter. The other reason is it's really easy to evolve the code as well. What I mean by that is, to me, what is programming? I'll tell you what programming is to me. Programming, to me, is a series of mini experiments. I never go to work knowing everything I do. I usually go to work and bang on the desk until my code works. And to me, it's a series of mini experiments. Would this work? Let me try this. Let me try this. Oh, what about this one? And for every single time I do this, it becomes really annoying, to the point where I sometimes ask this question: do I work? So does the compiler work for me, or do I work for the compiler, right? So this is something I'm not sure some days, because I'm sitting there and writing more and more and more code, and the compiler says, keep going, right? And I have to still keep putting more type information. It's not sufficient. But the point is, I want the compiler to work for me. I don't want to work for the compiler. So the point really is that by using var, you can let the compiler do some extra work for you without you having to struggle through all of that. It is easier to reuse the code as well. So if you're extracting a particular part of a lambda, and then you want a part of a expression, and you want to be able to reuse it in another place, you can simply store that into a nice little variable without having to put var, like in the case of collectors, for example. I'm going to say it's a lifesaver when it comes to debugging. Now, remember, when you're debugging code, you have a function that receives the data and sends it off to this other function. And you are looking at this function where within the parenthesis, you have this call to this other function, and you're thinking to yourself, let me find out what this value is that I'm getting from this call, and I want to know what I am sending over here. So what do? You immediately move this over, and you put a temp over there, and then you pass the temp. And what does the compiler tell you? The compiler says, not so fast, do you know what type temp is? And your answer is, I don't care, because I'm trying to debug this code. I just want to take a peek at it. And the compiler says, but you got to pay your taxes. You have to tell me what the type is before you can go forward, right? Now, why am I fighting this? All I want to do is take a peek at it. I'm going to just go back and put the code the way it was after I debug it. This can be really a lifesaver when it comes to debugging. I don't have to worry about it. One of the other beautiful things about this is that you can deal with what's called a targeted intersection types. What does that really mean? So to understand this, let's take a look at something a little bit different here, if you will. Suppose I have a list over here, and I'm going to say object over here called values, and I'm going to say over here, let's say new array list of object. Again, just entertain this thought for a minute. And then I'm going to go ahead and add, let's say 1, and I'm going to add, let's say, hello. I know this doesn't look really that clever, but let's entertain this thought for a minute. So I'm going to say values over here, and you can see 1 and hello as being part of it. Now, on the other hand, I'm going to say values.add a new sample, and I'm going to add to it as well, and clearly the value of sample is sitting in there. Now, this is the opposite of what I showed you earlier. Now, if I were to go back over here and turn into var and execute the code, you can see 1 and hello being there. Now, the question is, what's the type of values? Well, the short answer is values is array list of object, but not so fast. The compiler is extremely smart. The compiler does a series of analysis and comes back and says, you know, this is an array list of not object, but an intersection type. It can figure out what the values in here are, and it determines that there's something common between 1 and hello. 1 is an integer and another is a string. Well, the easiest way to know that would be to really go ahead and put that in there. So let me just change this a little bit to see that in action right here. So I'm going to say arrays.asList, so the compiler can actually infer that a little bit better. So let's go ahead and try this again. Let's make this a list of string for a minute. So don't worry about the runtime error, if you will, but let's look at the compatibility of these two here. Sorry, this is object. So let's look at the compatibility of these in here, and that's a runtime error. Just ignore that because it is immutable. Well, not quite immutable, but anyway, let's not go there. Don't worry about the runtime error. The compiler was happy with this. But the point really is, I'm going to now change it to a var right now, and notice that's a compilation error right now, and it tells us the intersection type is object and serializable and comparable. So it walks an extra mile, okay, several extra miles to determine the type over here and found out what it is. The last thing I want to show you here before we go forward with this is one other thing, which is pretty darn good, which is about the non-denotable types. So to understand this, let's look at one example of this particular code I'm going to show you here. So let's go ahead and look at this little example here. Notice I have a get price, which returns some random value. I have a list of ticker symbols, which is holding on to some, arbitrary stock values. But what do I want to do here? Now I'm going to say tickers dot, and I'm going to get a stream. I'm going to do sorted on it. So I've sorted all the symbols. Then I perform a map operation. Then I say collect to list, and I'm going to put this back into a list after all, and then we will see what I'm going to do with this in just a minute. So now that I'm going to create a list, what am I going to send to the map method? Well, I really wish Java had tuples, but Java doesn't have tuples. But I want to really create a very lightweight object where I have the ticker symbol and I have the price. So how do I do that? I'm going to say the ticker right here, and I'm going to then say is arrow new object, and I'm going to create an object where I will say string ticker is equal to the ticker, and then I'm going to say int price is equal to, and I'm going to say get price the ticker. So I just created an anonymous object right here on the fly. So let's make sure the compiler is still happy with it. We'll come back and process this in just a minute. So I'm going to just say OK to see if it was happy with it. Well, not yet, but let's go ahead and make it happier. So right there, it was happy with the saying OK. But the question is, what is the type over here? Now, the problem is that is a non-denotable type. The compiler knows what the type is. It won't tell you. So you're like, could you please tell me what the type is? And the compiler is like, it's my little secret. I won't tell you. Well, OK, let's play by the rules then. Var result is equal to. So you're telling, hey, compiler, this is of the type whatever it is. And the compiler is like, damn it, you got me now. So you basically are working with it to say, whatever the type is, I'm going to go with it. So this becomes a really interesting way. It doesn't have a far-fetched really application, but it can be useful in some small context. So for example, I can say result dot for each right here. And then I can say over here, let's say stock price, or whatever the stock price is, using type inference one more time. And I'm going to now go ahead and output a stock price right here. Let's take baby steps right now. We'll come back to that. Well, that's some object, but I really want to get stock price dot ticker. Notice all of a sudden, I'm able to get the value out of it. And then I can say plus, maybe a little colon, and then a plus again. And then we can say stock price dot price. And now the compiler is like, I'll work with you. So this becomes a really interesting way to pull information with non-denotable types. And this is something you cannot do without having the ability to do var. So you're kind of playing by the rules of the language. Like I said, you won't use this too extensively, but this is really useful for local context where you have a non-denotable type and you want to immediately use it. This can be a really powerful way to use it. So with all that said so far, let's talk a little bit about do's and don'ts to summarize. Well, oh, sorry, one more thing. About Java 11 I want to talk about real quick. So what does Java 11 introduce? So let's talk about Java 11's, so I already talked about this part. Java 11 has one little feature, which is you can do var in Lambda parameters. Now, at the first thought, that looks really ridiculous, isn't it? Like, why would we want to do that? But there's a really good reason. So to understand this, let's look at an example. Let's take a list of numbers again, numbers.for each, and what you can do here is given an element, output the element. We saw this earlier. We're using type inference. What you can do here, though, is you can put over here a var like this. Now, the question is, why in the world would you do that? Well, the reason really is not because we have a desire to put var everywhere. The reason is, if I really wanted to put an annotation, like final or at not null, I couldn't do that before, but I can put that with a var. That's the reason why they have this in Java 11, is because you can annotate your parameters without getting dragged into the type information. So don't use var in Lambda parameters unless you put an annotation in front of it. If somebody is using var without annotation, there's really no reason to do it, right? They're just complicating this more than they should. There's no reason to really make that complex. So that's the reason really to bring that in. And you can explore a few other limitations around it, things that you would be able to figure out fairly easily, because if you violate those, the compiler will give you an error, so we don't have to really talk about it. So let's summarize this with some do's and don'ts. The first is, please don't use var with an angle diamond operator. We saw this earlier because the inference would default to object type, which is probably not what you really want to. Oh, another thing, this is an anti-pattern. I see people do this quite often. For example, I see this, I do a lot of code reviews, and I always correct programmers when they do this. A list string names is equal to, let's say, arrays.asList. let's say Jack and Jill for a minute. Now, you look at this and say, I want to print the names obviously here, but I want to go ahead and change this to use the type inference, and you will see programmers put a var, and they will quietly go here and say names list. This is when they're clinging on to the type information, right? This is an anti-pattern. This is like using, what is it called, Hungarian notation, right? That fell out of flavor. If you do that, 1996 is calling you again, right? So there's really no reason to do it. So don't put type information with variables. Just let it go. That's really important to just say, you know what, we'll just deal with it. No need to put it. The other thing I will also say here is, suppose you're working in a team where somebody is really having a desire to name variables as P, K, Z, and W. var will not help you because you're working in a hopeless team already. So there is absolutely nothing var can do. A really good name for variables is still required to make sense out of the code. Make sure the type is what you really wanted to. We saw examples of this a few minutes ago. Specify the type unless it's dead obvious. It's clear to me, no ambiguity. Give it to a colleague and say, is this obvious to you? If it's obvious to the other person also, go for it. Use var for temp, use it for debugging purposes, use it for reusing code, use it for annotated Lambda parameters. But if you're in doubt, just simply don't bother. You don't have to use var. There is no reason to get into fist fight with your team. Var is not worth it in my opinion. I love var. I use it very extensively. But at the same time, I'm very sensitive as well. If a colleague of mine finds it really hard to use it, I wouldn't use it in that particular case. In a way, you could argue that var should really make it easier to understand the code. Also keep in mind that it sometimes takes us a little bit longer to get used to things. Sometimes you may have a developer who is not really happy with it today, but don't force them into it. Just give them a little space, give them a little time, and a year later, they'll quietly start using var. At the time, just follow along and start using var. That's because they just have taken time to get used to it, and there's absolutely nothing wrong with it. After all, we just want to be very comfortable writing the code, and because the developers in your team are the ones who are going to maintain this code after all. I hope that was useful. Thanks for being here.